4.2 and 4.3, or these two sections together, are going to have a lot of stuff you should have already learned back in middle school somewhere. They're going to talk about classifying triangles by their angle measures and their side lengths. Be super careful about the directions. If it's angle measures, it's going to have a name. If it's side lengths, it's going to have a name. If they say classify it by side lengths and you give me an angle measure name, you won't get credit. So make sure that you're reading your directions really carefully. Okay, that's the thing I notice often students make a mistake with. All right, so we're going to start with that, and then we're also going to find side lengths and measurements using some of these classifications. There'll be lots of theorems that we'll talk about today. These are the things that I think you should already know. You should know what is an acute triangle, what's an equiangular triangle, what's a right, what's an obtuse, what's an equilateral, what's isosceles, and what's scalene. Would you agree that you maybe at least have heard those words before? Okay, so we'll see how much you remember and how much we need to go over. Before we get started, though, just that picky notation that you keep seeing the -1/2 for, I want to warn you about. When you name a triangle, you have to put the little triangle symbol in front of it. So any triangle that you're naming, make sure you put triangle, ABC, whatever. The sides of the triangle are line segments, and so when you name the sides, make sure that you are naming them as line segments, AB, AC, or BC. A, B, and C are called the vertices, so that's important. All right, and then we're going to look at all the triangle classifications. We're going to start with by angle measure. It's kind of hard to read that because it's really dark on your notes. But do you see up here where it says by angle measures? Can you kind of see it in your notes? It's pretty dark. Okay, so the next few vocabulary words are based off of angle measures. So if they say classify the triangle by angle measure, you're going to give me one of these names. So the first one is acute. An acute triangle should have all acute angles. What does it mean to be acute? Okay, less than 90 degrees. So every angle would be less than 90. If it's equiangular, also very misspelled word is equiangular. There is no L. It is not equal. It is equiangular. Equiangular is going to have all angles congruent. So all three angles will be congruent. What do all the angles in a triangle add up to equal? 180 degrees. So think about that with me. If all three of them are 180 degrees and they're all the same, what should each angle be? 60, because if we take 180 and divide it by 3, we get 60 degrees. So as soon as your picture shows you that it's equiangular, you should automatically know that that means each angle is going to be 60 degrees. Okay, super important. And I would write these things down to have it to look back at. All right, right triangle is going to have one right angle. Is it possible for a right triangle to have more than one right angle? No, why not? Well, not necessarily.
A triangle has 3 angles.
Mm-hmm.
If it's 2 right angles, then it already adds up to 180.
Exactly. So if it has more than one right angle, then it would already be 180 degrees before you add in that third angle, and that's not possible because all three angles always have to add to be 180. So it's only going to have one right angle. An obtuse triangle is going to have one obtuse angle. What's it mean to be obtuse? Okay, greater than 90 but less than 180, okay? So it's going to have one obtuse angle. Is it possible to have an obtuse angle and a right angle in the same triangle? No, because again, that would already be over 180 degrees, and all three angles have to add to be 180. Those kinds of questions are the things you might see on a test, always, sometimes, or never. So a triangle, always, sometimes, or never, has 2 right angles. And you would say, never, okay, because you can't have 2 right angles. A triangle, always, sometimes, or never, has 2 acute angles. Sometimes, okay, it can. They don't have to. It could be, well, actually, it's always. Thank you. It would be always, because think about it. If it's a right triangle, what are the other 2 angles going to be? If it's an obtuse triangle, What are the other two angles going to be? Acute. And if it's equiangular, they're all 60, so that makes them all acute. So yes, it would be always. Good, Anna. Okay, so those are the kinds of things that you might see on a always, sometimes, never question. All right, so now we're classifying. Make sure you're clear. Classify means give it a name that's either obtuse, right, acute, or equiangular, since we're basing it off angle measures. So we're looking at triangle BDC. So look at triangle BDC. Find that triangle in your picture. Based off the angle measures, what kind of triangle would that be? It's obtuse. The 100 degrees is referring to this angle right here, angle B. And so if we have an angle that's greater than 90, that means we have one obtuse angle, and the definition then says that it is an obtuse triangle. Okay, let's try another one. Same picture, different triangle. Classify triangle ABD by its angle measures. So find ABD. We're looking at this triangle right here. 80 is pointing to angle A. 20 is pointing to angle ADB. Okay, so you think it's acute. What are we missing before we should make our decision? The other angle. If this one's 80 and this one's 20, how much is that total? 100. And so what does that mean? This other angle has to be here that's missing ABD. 80. So can we say for sure now that it is acute? Yes. So you may have to find a missing angle before you really make your decision. And I would suggest you do that just to be confident. So this is an acute triangle. Any questions on classifying by angle measures? Okay, let's go on to classifying by, this should say really hidden there in your dark print, by side lengths. So now you're going to have some names of triangles based on their sides. So the first vocabulary word is equilateral. This one does have an L. Equal, because it's equilateral, and lateral has an L. So equilateral triangle. Equilateral means that it has all three sides congruent. All three sides are congruent. Isosceles, very commonly misspelled word. So make sure you can spell isosceles. This is the one that catches a lot of students. Its definition is probably not what you were taught at a younger grade. Most students come in here telling me that isosceles means two congruent sides. Isosceles does not technically say just two congruent sides. It says at least two congruent sides. At least two congruent sides. So if it has two congruent sides, it is isosceles. But if it has all three sides congruent, it's also isosceles. It's just more specifically what? Equilateral. So here's where it can get you. Always, sometimes, or never question. An equilateral triangle is always, sometimes, or never isosceles. Always. Let's flip it. An isosceles triangle is always, sometimes, or never equilateral. Sometimes. If it's isosceles, it's going to have at least two congruent sides. Could it have three congruent sides? Yes. If it does, it would be equilateral. If it just has two, then it's not equilateral. So it would be sometimes. Does that make sense? Okay, so isosceles definition is at least two, not just two. That's the kicker. And then the last one is scalene, and scalene triangles have no congruent sides. So all the sides will be different lengths. Okay, I want to emphasize this helpful hint right here. Did I put this, or this remember, did I put this in your notes? Okay, when you look at a figure, do not ever assume that segments are congruent based on their appearance. Do not assume that an angle is acute because it looks acute. Do not assume that it's obtuse because it looks obtuse. They will purposely draw pictures not to scale because they're trying to check and see, do you know how to use the theorems you're learning? So you may get that the angle is 150 degrees and it looks like it's 60. Doesn't mean you're wrong. It just means the picture's not drawn to scale. So be careful. Don't assume anything. You can only go off what has been marked. Look at your markings. Okay, that's what's important. All right, so back to classifying. Classify again means give it a name. This time we're naming it based on the side lengths, so not the angle measures. We're looking for names like equilateral, scalene, isosceles. So when you look at this one, we want triangle EHF. What kind of triangle is EHF? Isosceles. We know for sure these two sides are congruent. This one's 10, which makes this one 10, but this one is 12. So that means they're not all three equal, so it's just isosceles. Okay, any questions on classifying? All right, the next few problems we're going to look at are what do we do if they give us a picture and we are trying to figure out measurements, side lengths, angle measures, and so forth. Most common mistake I see in this chapter with algebra is I will have students look at this picture or look at a picture. Let's say this one, I'm going to make up a different one up here real quick. They'll look at something like this. And they will tell me that all three of these sides add to equal, what do you think they add to equal? 180. What is 180 referring to? The angles. And angles are measured in degrees. Are side lengths measured in degrees? No. Sides can get infinitely bigger. The triangle can get bigger and bigger and bigger. There is no sum that the sides sum to. They can just get larger and larger and larger. The angles, however, when your triangle grows, stay consistently the same size. It's just the side lengths getting longer. So your angle measures are what are going to add to be 180. They always sum to 180. But your side lengths, there is no sum for those. Okay, so be really careful that you don't do that. Do not add side lengths and set them equal to 180 degrees. So over here, what kind of triangle do we have? Isosceles, based on your markings. Notice one mark, we have an isosceles triangle. What does that mean about those two sides? They're congruent, which means they're equal. So what could we do if we wanted to find the side lengths of this triangle? Very good. I heard several of you say that. Great job, Weston. You would just set them equal and you would solve for x. And then once you find x, you would plug it back into the picture to find your side length. So let's do that real quick. What do you want to do to solve for x? Add 10.7. Okay. And then what? And then what? And so x is equal to 8.5. That's not our answer. That's the value of x, although it might be your answer on your homework if it just says find x. So make sure you read your directions carefully. When we go to plug it back in, do we have to plug it back into all three sides? No. What sides do we have to plug it back into? Okay, because these two are the same, they should have the same measure. You can plug it into both if you want to make sure that you've done it correctly, but you don't need to. Which one do you guys want to plug it into? Okay, 2x plus 6.3. So 2 times 8.5 plus 6.3. What's 2 times 8.5? Good. So we have 17 plus 6.3. And what is that? 23.3. So that means when you write your answer, KL is equal to 23.3. So is JK. It is 23.3. Remember that you do not put a line segment above KL or JK. You're giving me the distance. Distance does not have a line segment above it. And then we need to find JL. So let's plug it in here for 5x plus 2. 5 times 8.5 plus 2. What's 5 times 8.5? 42.5. And 42.5 plus 2 is 44.5. So we end up with JL is equal to 44.5. Any questions on those? Okay. The next example you're going to see what is different on it compared to this triangle. Okay, so it's equilateral. What does that mean that we need to do if it's equilateral? Do we need to do anything different? What do we need to do? Okay, so just because it's equilateral, all that means is that all of these should be the same, right? They tell us up here that it's equilateral. So that just means all the sides are the same. So we're not going to set them all equal to each other. We just need to do what? We need to solve for y by doing setting two of them equal to each other. It doesn't matter which two. You could pick the left and bottom. You could pick the right and bottom. It does not matter. You could pick the left and right. Which ones do you guys want to set equal? Okay, so the 3y and the 2y? Okay, so we'll set these equal to each other. 3y minus 4 equals 2y plus 3. What do we want to do from there? Add, excuse me, I'm sorry? Add 4. So 3y is equal to 2y plus 7. What do you want to do from there? Subtract 2y. So we have y equals 7. Again, watch your directions. It may be that that's all you have to do, but the directions up here said find the side lengths. How many times do we need to plug it in? Just once. They're all the same. So it doesn't matter where you plug it in. I'll plug it in over here where we have 2y plus 3. What's 2 times 7 plus 3? 17. 14 plus 3, which is 17. So when you write your answer, make sure you list it for all the sides. FG is equal to 17. GH is equal, oops, I gotta click over here, I'm gonna mess it up. GH is 17 and FH is 17. All right, any questions? You guys are so quiet. All right, I want you to take a minute and try the next word problem on your own. See if you can read through it and if you can figure it out. You're welcome to talk to the person behind you or beside you. I know we're not in pairs today, but feel free to help each other if you want to. Just try this problem right here. Different approaches though, which I love to see. So I see some of you have drawn a picture, 18, 18, and 18. Some of you decided you would figure out how much does it take to make one triangle first. So how much does it take to make one triangle? 54. So you found the perimeter for one triangle was 54 feet, right? And then you said, okay, I have 420 feet of steel, so I can take this 420 and divide it by 54. 54 goes into 427 times 7 times. 7 times 4 is 28. Carry your 2. That's 35, 36, 37. Subtract, and we end up with, check my math, make sure I'm doing this right. Is this correct? Okay, and we could keep dividing, but we're going to be left with 42 out of 54, which we could reduce. And that's all that we can make. So can we make 8 triangles? No, we can make how many? 7. So we would say that we can make 7 full triangles. But I saw some of you didn't work it that way. Some of you said, okay, I'm going to take 18 and divide it into 420. And found that answer. So how many times will 18 go into 420? Okay, 23 times. So let's start with 2. We get 36. Subtract, we get 6. Bring down our 0. 18 goes into 63 times. 3 times 8, 24. Carry our 2. That's 54. And we're left with 6 out of 18, which could reduce to 1/3. So we have about 23 times that 18 will go in there, but that's only taking one side of our triangle, right? So what would we need to do with 23 to count in? We would need to divide it by 3. So we have about 23 here, but then we would need to divide it by 3 because we need 3 of those sides. So when I take 3 into 23, I'm again going to get 7 point something, and that means we can only make 7 triangles. So different ways to approach it, both great ways. Any questions? All right, we're going to skip the last one then, and let's move on to 4-3. Okay, so 4-3 says find the measures of the interior and exterior angles of a triangle. Well, first of all, we need to talk about what is an interior versus an exterior. And we need to talk about some vocabulary. So we've got auxiliary line, corollary, those are different things we've never talked about. Interior and exterior, you probably have an idea of what that is. Interior, exterior angles will be a little bit new. And then we're going to talk about remote interior angles. So first, theorem, and you're going to need to know the name of this theorem, so make sure that you study this. You already told me this theorem, though, just a little bit ago. I asked you, what do all the angles in a triangle add to B? And you guys said 180, okay? You already knew that. What you may not have known is that it's called the triangle sum theorem. So if we use it in a proof, you're going to need to know that it's the triangle sum theorem. So if you want to add all the angles together and set them equal to 180, that's triangle sum theorem. Okay? The next thing that we're going to talk about here is so important, but we don't use it today. So we talk about it in this lesson, but you don't use it on tonight's homework. And then next week, when we need to use it on the homework, you may forget about it. So try to make good notes right here. Take notes on your paper. I'm going to write some stuff down, super important, and you won't need it tonight, but you will need it next week. So next week, we're going to be writing 2-column proofs. We're going to be trying to prove triangles are congruent. When we do that, sometimes there's not enough information in the picture. And in order to prove that the triangles are congruent, you need to draw in a line. If that happens, that's called an auxiliary line. An auxiliary line is just a line that is added to a figure to aid in a proof. Here's where it's going to pop up on your homework. They're going to give you a picture like this. And they're going to ask you to prove that triangle ABD is congruent to triangle CBD. What do you notice when you look at this picture? What's the problem with us trying to prove 2 triangles congruent when I look at the picture? Okay, we don't know for sure where D is. That may be a problem later based on what information is given. What did you say over here? Okay, there's not 2 triangles in the picture, right? There's 1 triangle. So what are we going to need to do to get 2 triangles? Okay, make a line. And what line do we need to draw? Okay, but what specifically in this picture? Where do I need to draw the line? From D to B. So I need to draw a line here from B to D. Can't draw straight, sorry. Yes. So B to D needs to be drawn. Now we have 2 triangles. So when you get a problem like that, and it will be very obvious, just like what I showed you here, then what you're going to do in your proof, and this is what you need to write down, super important. So draw this picture, write this down. Because you're going to get stuck on your homework, and you're going to need to come back to this set of notes to see what was I supposed to do again if I need to draw a line. So if you're in your proof and you realize I can't do this proof without drawing a line, then what you're going to do in the proof is you're just simply going to write draw, and you're going to draw a line. You're going to name the line that you're going to draw. So our line that we're going to draw was BD, right? So we're going to draw line segment BD. So we'll just put draw BD, and then the reason will be the definition of auxiliary line. Definition of auxiliary line. It's not going to happen a lot. You are not allowed to just draw lines anywhere you want. It's only if there is no way to do the proof without having another line. Does this make sense? Okay. Again, I hope you wrote it down because you will need to come back to it when you get to that section. So what they're showing you here is that we could have proved the triangle sum theorem using what we already know to get to here. So if I were to draw in this line, this would be an auxiliary line. What do we know about the sum of angles 4, 2, and 5? They have to equal 180 because it forms a straight line. So we know that the measure of angle 4 plus the measure of angle 2 plus the measure of angle 5 equals 180. Okay, if I draw in that auxiliary line so that it is parallel to AC, and this is good review of what we just did in chapter 3, what do I know about angles 4 and 1? They're congruent, they're the same. What kind of angles are they? What's the name of them? Alternate interior angles. So that means where I have a 4, I could put measure of angle 1 by substitution, right? Okay. And then what do we know about angles 5 and 3? Very good. And so that means they're congruent, right? So where I have a 5, I could put a 3. And then if I keep my measure of angle 2, look at what we have. 1 plus 2 plus 3 equals 180. And that's our triangle sum theorem, that all 3 angles in a triangle add to be 180. I didn't write that as a formal 2-column proof, but you can get the idea. Does that make sense? Okay. So if you have to draw a line, it's called an auxiliary line, and you just write, draw that line, definition of auxiliary line. Okay. So then this is kind of a stretch. They give you this information. Read that for a moment. So they're trying to say that there was a car accident and the policemen were out there at the scene and they were drawing lines to measure this, maybe the skid marks and where the cars are, and it turned out to look like this picture. I think that's a little bit of a stretch. Probably isn't going to look like this picture, but maybe. I haven't been on a lot of crime scenes, so what do I know? But maybe that's happened. So they're trying to make a connection of what you're learning in this section to a real life situation, but I highly doubt it's going to turn out and look exactly like this. But maybe. So what they want you to do, all of that wording, to just simply say, find the measure of angle XYZ. Okay? So that's what we're trying to find. X, Y, Z. This angle. That should be pretty easy after what we just talked about. What do we know all 3 angles in a triangle add to equal? 180. So they give us this angle is 62, this angle is 40. What would we need to do then to find the one we're looking for? Okay, so what is 62 plus 40? 102. And what is 180 minus 102? 78 degrees. So this is just 78 degrees. Don't forget your degree symbol. Don't forget your little M when you're naming the angle measure. Any questions on that one? Okay, go ahead and look at the next one. Same picture, I believe. Different angle that they want you to find, though. They want you to find YWZ. And I think your picture has some information on it that mine does not. So they want us to find YWZ, this angle right here. Okay, what's on your picture that's not on mine? Okay, so they said WXY is 118. You should have been able to get that, though, without it being given. How do we know that this angle right here is 118 degrees? Okay. Good. It's supplementary to 62. What kind of angles are these 2 angles here? What do we call those? Linear pair. And linear pairs are always supplementary. So if they gave us this with 62, you should be able to find that this angle is 118, right? So it may not be on your picture, even though it is on the notes I gave you. So now that we know this is 118 and this is 12, can we find that angle? So do you have any parallel lines in this picture? Nope. So all of those things. Okay, but everything you learned in chapter 3 was if you have 2 parallel lines cut by a transversal. None of the stuff we learned is true unless you have 2 parallel lines cut by a transversal. So right now you have one horizontal line, but you don't have another one anywhere that's parallel to it. Does that make sense? Okay. So this is 118 degrees. This is 12. How do we find W?
118 plus
Okay, and what is Anna 118 plus 12?
130.
All right. And so if it's 130, Truman, what would I do to find angle W? Sorry, if I'm looking for angle W, Anna said that we could take the 118 and the 12 and add them together to get 130. How can I find this angle W then? Exactly. And what is 180 minus 130? 50. Okay, so then our answer would just be 50 degrees. Everybody with me? All right. I want you to take a few minutes and look at the next one. It is too hard to read probably on your paper. You and your partner or somebody around you, feel free to work together. But look up here at the board. It's easier to see up here. There's some things that may not be marked good enough on your paper. So I want to point them out real quick. Do you see this little red arc and this red arc? Do you see them on your paper? Okay, so what does that mean about those two angles? They're the same. All right, so I want you to take a minute and see if you can find the measure of this angle. And then we'll check. But they wanted you to find MJK. So if you look up here, it's a little easier to see. M to J to K, you're supposed to be finding this angle. Okay, can you see it better there? So I noticed a lot of you took 88 and 48 and added them together. And what did you get? And then you took that 136 and subtracted it from 180. And what did you get? 44. Good. And then that was this angle right here. Agreed? And then because this arc and this arc are the same, we know that this angle is also 44. And some of you stopped there because it was hard to read the picture and you thought that was the angle you were looking for. But be careful, they wanted you to find this one. So if this is 104 and this is 44, we can do that same process again. 104 plus 44 gives us what? And then we take 148 and subtract it from 180. And what do we get? 32. And so that is this angle that we're looking for, 32 degrees. Everybody with me? All right, good. So now we have a few theorems that we need to talk about, and then we're going to use those theorems to find missing measures. But before we do that, we need to talk about the word corollary. So a corollary is just another name for a theorem. Why do they give it a special name? Well, the reason they give it a special name is because sometimes you will have theorems that follow really easily or really quickly from another theorem. So I used to say easily, and then a lot of students would say, there's not an easy proof, Miss Lashley. That's not true. So instead of saying easily follows, let's just say quickly follows, okay? So a corollary is a theorem whose proof follows directly or quickly from another theorem. And I think you'll find that these do come really easily from other theorems we've already learned. So the first corollary does not have a name, but it simply says that if you have a right triangle, then the other two angles are going to have to be acute. And because all three angles add to be 180, if I take away 90 degrees, how much is left? 90. And that means that D and E are going to have to add to be how much? 90. And what do we call it when two angles add to equal 90 degrees? Complementary. So this corollary says that if you have a right triangle, the other two acute angles will be complementary. Not necessarily 45 and 45, that could be true, but they can be any numbers that add to be 90. So it could be 30 and 60, 20 and 70, 5 and 85. It doesn't matter, but together this angle and this angle should have to add to be 90. So a shortcut, if I tell you it's a right triangle and this one is 30 degrees, do you need to take 90 plus 30 and add it and then subtract it from 180? No, you could quicker just do what? Exactly. Take 90 and subtract 30 because these two have to add to be 90. So it's faster if you use this corollary. Okay? The second corollary we already talked about. I asked you, if all three angles in a triangle are equiangular, and we know they add to be 180, what does every angle have to equal? And you guys said 60. So that's what this says. The measure of each angle of an equiangular triangle will always be 60 degrees. If they tell you it's equiangular, you can say every angle is 60 degrees. Okay, so just some things you can use when you're solving problems. All right, so then we get to a couple questions that are a little bit harder and always cause some confusion. So make sure you're writing these down for sure and looking at them with me. So it says one of the acute angles in a right triangle measures 2x. What is the measure of the other acute angle? Not necessarily. Remember, they don't have to equal each other. You don't have to have a 45 and a 45. It could be 20 and 70. So we don't know for sure what that other angle is. It doesn't have to be the same is what I'm trying to say. Okay, so Anna is correct. If you think about it visually, maybe that'll help you if you're struggling a little bit. If you have a right triangle and one angle is 2x, bless you. The other angle we just learned, these two angles are what? Complementary, okay? They don't have to be congruent. Remember, again, you could have a 5-degree angle and an 85-degree angle, a 20 and a 70, a 30 and a 60. They could be 45 and 45, but they don't have to be. They just have to add to equal 90 because this one is 90, and the total has to be 180, okay? So we know they have to add to be 90 degrees, and so Anna said that means that this angle has to be 90. Oops, not bad, I just messed it up. Hold on. There we go. This angle has to be 90 minus 2x. And that's as far as you can go. That would be your answer. Don't make it harder than it is. So whatever this angle is, to find the other one, you would just do 90 minus that angle. If it's a number, you can simplify it. If it's an expression, that's as far as you can go. This one should be 90 minus 2x. Does that make sense? Okay. Ooh, it's fancy. All right, so let's try this one. This will make us practice our proficiency skills. Same directions. The measure of one of the acute angles of the right triangle is 48 2/5 degrees. What is the measure of the other acute angle? So again, visually, if you would like to draw yourself a picture, you can. You have a right triangle. One angle is 48 2/5 degrees. How are we going to find the other angle? Exactly. Use that shortcut. Don't make it harder on yourself. Don't add these and set them equal to 180, or add these and then subtract from 180. Just simply know if this is 90, then these two have to add to equal 90. So that means I can just simply do 90 minus 48 2/5. Okay, practicing subtracting with fractions. Here's something, the way I would work it if I were you, so if you're still struggling with that on the proficiency test, I would borrow from this 90 and make this 89 and take that whole and make it a fraction. So what is a whole in terms of fifths? 5/5. And then subtract straight down. What is 5/5 minus 2/5? 3/5. What's 9 minus 8? And what's 8 minus 4? So it's 41 3/5 degrees. Any questions there? Okay, that's your shortcut. If it's a right triangle, the other two acute angles will always be complementary. Okay, interior versus exterior. So we have not ever talked about an exterior angle in here, I don't think. Only interior angles. When we've looked at shapes, we've just talked about their angles inside. So when you think of interior, what do you think of? Inside. When you think of exterior, what do you think of? Outside. So same idea. Exterior is going to be the set of all points outside the figure, and interior is going to be the set of all points inside the figure. So that should be easy on your vocabulary test, interior versus exterior. But now let's talk about interior angles and exterior angles. So interior inside the shape, exterior outside the shape, and then you'll have points that are on your shape. These are not interior or exterior, but they're on the shape. The angles, if you're talking about an interior angle, that's what we said adds to be 180. So angle 1, angle 2, angle 3, those are inside, they add to be 180. An interior angle is formed by two of your sides of your triangle. So where any two sides meet, they make an interior angle, right? An exterior angle, this is important, the definition, because every year students want to think that there's more than one at a vertex. Look at the definition. An exterior angle is formed by one side of the triangle, so it stays the same, and the extension of the adjacent side. So you're going to take one side of your triangle and leave it alone, and then you're going to extend out the other side of the triangle. So you only extend one of them. If you extend one, then that's an exterior angle. And there is an exterior angle at every vertex. And it doesn't matter which one you extend out. Just extend out one side, it creates an exterior angle. So I've got an exterior angle here, here, and here. One at every vertex. Does that make sense? Okay, what is going to be true about every interior angle and its adjacent exterior angle? Exactly, because they're going to be what kind of angles? A linear pair. So if they ever give you the exterior and you're looking for the interior, just subtract it from 180, okay? So we have these three exterior angles. And I want us to look at this next theorem that's going to come up. It's going to talk about a remote interior angle. But before we do, I want us to see if we can discover this next theorem. So I'm going to write this down. Follow with me on the board. What did you just tell me will be true about angles 3 and 4 in this picture? They add to equal 180. So it's okay if I write measure of angle 3 plus measure of angle 4 equals 180. We all agree? Okay. What do we know about 1, 2, and 3 in the picture? Okay, so the triangle sum theorem says the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 also adds to be 180. Okay, what property says that if they both equal 180, I can set them equal to each other? There's not an equiangular theorem. Transitive property. Transitive property says that if I have one side identical to the other side, I can combine the other two parts. So if A equals B and B equals C, then A equals C, right? So I could say measure of angle 3 plus measure of angle 4 equals measure of angle 1 plus measure of angle 2 plus measure of angle 3. Do we agree with that? Can you see, Jackie? Sorry. Okay. So if I look at those two, what do I have on both sides of the equation? Measure of angle 3. So if I subtract the measure of angle 3 from the left and subtract the measure of angle 3 from the right, those angle 3's are going to cancel out. Agreed? And so now we have the measure of angle 4 is equal to the measure of angle 1 plus the measure of angle 2. And that is the next theorem that they're going to give us in the notes. So let's look at what that looks like. Angle 4 is the angle that is outside the triangle. This says that angle 4 should equal the sum of angles 1 and 2. 1 and 2 are called remote interior angles. They are the angles that are inside the triangle that are not adjacent to the exterior angle. Okay, so making sure we all have our head wrapped around this. What's the exterior angle? Which number? 4. Which one is adjacent to 4? 3. So the ones that are not adjacent to 4 are called remote interior angles. When I think of remote, I think far away. Not the remote that we click with, but remote that's far away. So the angles that are far away from angle 4, not the one right next to it. So if you have an outside angle, an exterior angle, it's going to equal the sum of the two remote interior angles. And that is the next theorem that you'll see in your notes. It's called the exterior angle theorem. So if you'll flip that over, it's really important. You will use it a lot throughout this course. Exterior angle theorem. So again, if you have a picture and you're trying to solve for a missing angle measure somewhere, the exterior angle will equal the sum of the two remote interior angles. Mrs. Ashley? Yes. Yes, does she need to come right this minute? Okay, I will. You bet. Thank you. Bye-bye. Marissa, you need to go to the counselor's office and take your stuff. Here's the assignment. And just make sure in about 45 minutes, try to watch the rest of the video, okay? For the part that you miss. Okay, are we all good with me? We're so tired and quiet. Okay, let's see. I'm going to call on you. I need you to talk to me. So we're looking for measure of angle B using what we just learned. Let's go with Naya. What's the outside or exterior angle? BCD, which is the 5x minus 60, right? And so what did we say that that should equal according to the exterior angle theorem? Alexander? There you go. Very good. Exactly. So the exterior angle should equal the sum, make sure you're adding, the other two angles that are inside, not the one that's adjacent to it. All right, so then we just go through and solve. The algebra part's going to be the easy part. So combine like terms over here. What's 15 plus 3? 15 plus 3? 18. Okay, and then we have 5x minus 60 on the left. What do you guys want to do to solve? Add 60. So 5x is equal to 2x plus 78. Subtract 2x. 3x equals 78. Divide by 3. What do you end up with for x? Anybody else get an answer besides Bree? How many times does 3 go into 78? 26 times. Good. So x would be 26. The question, though, didn't say find x. What did it say to find? B, so we have to plug it in. So I go over here to B. The measure of angle B should equal 2 times 26 plus 3. What's 2 times 26? 52 plus 3. 55. And that would be our answer with degrees. Questions? We're good with exterior angle theorem? Okay, if you look at the next one, I'm not going to work it all the way out. Let's just set it up for time purposes. If we look at the picture, though, what's the exterior angle? Let's go with Emmeline. 6z minus 9. And so, Denise, what should 6z minus 9 be equal to? Very good. 2z plus 1 plus 90. So we have that other angle that's in the picture is a 90-degree angle. So you're always using the two remote angles, not the one right next to it. And again, what do we know about the two that are right next to each other? That adds equal 180 because they are a linear pair. So it may be that you go through all this work and you solve for z, and then you plug it back in to find this angle, but that's not the angle they want you to find. They might want you to find this one. And then you would just subtract that from 180 because they're a linear pair. Does that make sense? Questions? Okay, I'm going to skip this one then. We've got it set up. You can go through and solve it. And let's look at the last theorem that you have here. And I cannot stress enough about how important this theorem is going to be next week when we are doing proofs. You are going to use third angles theorem a lot. It is super important. Third angles theorem. Let me preface this with there is not a third sides theorem. Okay, super important too. Not a third side theorem, third angles theorem. So third angles theorem says if two angles of one triangle are congruent to two angles of another triangle. So you look at the picture, you've got L's congruent to R, S and M are both congruent. right? So we've got two angles in each triangle that are congruent. Think about this with me. Somebody give me a measure for L, any measurement. 28 or 20 degrees. Okay, then that means R is 20. Give me another measure for M. 40. So that means S is 40. What's 20 plus 40? 60. So what does the other angle have to equal? 120 degrees, which means in both triangles, that third angle has to be the same, right? So that's what this is saying. If two angles in one triangle are congruent to two angles in another triangle, then the third angles are congruent. Third angles theorem. So you have to have two marked congruent to two, and then your third angles will be congruent. So last examples you're going to see in your notes are going to require you to do a little bit more algebra and review some algebra that's important. First thing though is you've got these two triangles and they're overlapping. If we separate them, do you see that there are two angles marked congruent in one triangle and two angles marked congruent in the other triangle? Okay, so what does that mean about angles K and J? They're congruent. So you should be able to write down 4y squared equals 6y squared minus 40. Now let's do some algebra here. What do I do to solve? Subtract 6y squared. What do I get? Very good. And then what do I do? Okay, or I could just divide all at the same time by what? Negative 2. Okay, I could multiply by negative and then divide, or I could just divide by negative 2. What does that give me for y squared equaling? 20. Okay, and we are supposed to be finding the measure of angle K and J. So two things here. What do I do whenever I'm solving for y? Okay, I need to take the square root, right? When I take the square root, what do I get for my answer for y? Okay, square root of 20, but you're missing two things. Okay, so it should be plus or minus. Remember in Algebra 1, you guys should have talked about, if you have something like x squared equals 9, what number squared is 9? 3 or negative 3. There are always two solutions when your exponent is a square. So that means that x should equal either positive 3 or negative 3. So when we take the square root here and we say what squared is 20, we have to remember that that means it could be plus or minus the square root of 20. Are you with me? Okay? Because on the test, I may not ask you for the measure of the angle. I may ask you for the value of y. So you have to know that you have to take the square root, and then it should be plus or minus, and you should be getting two answers. Are you allowed to leave your answers as the square root of 20? No. We've talked about in here, I believe, remind me if I'm wrong, simplifying our square roots. Okay, so 20 will simplify. What does 20 factor into? 4 and 5. And what is the square root of 4? 2, and the square root of 5 cannot simplify. So y is actually equal to plus or minus 2 square roots of 5. If I asked you for the value of y, this is what I should see. You will miss points if you don't put plus or minus, and you will miss points if it's not simplified. But then you have to go to your geometry picture and make sure that both the positive and the negative answer will work. Can you have a negative angle measure? No. Can you have a negative side length? No. So you're going to have to go back and look at the problem and say, okay, if I plug in a negative number here, but then I square it, what's it going to do to the negative? Make it positive. So it will still work, right? If it doesn't, if you go to plug your negative measure in and it gives you a negative angle measure, then it doesn't work and you don't include it as your answer. Is that clear? So you have to check it for your geometry. In algebra, you would just stop here, you found y. In geometry, you have to go back and look and see, does it really work both solutions for my problem? So this would be the answer for y, but the question said find k and j. So we're going to go back and plug it in. I want to make sure we can do it both ways. This is your algebra. It's super important. So let's say I have 4y squared here, and that's equal to the measure of angle k. I need to plug in this 2 square roots of 5 in for y? Anna, make sure you're with me. And I need to square it. How do I square 2 square roots of 5? What does it mean to square something? Okay, multiply it by itself. So how do I square? I have 4 times 2 square roots of 5. I'm going to multiply it by itself, 2 square roots of 5. How do I multiply that? Say it again. I'm going to come back to what we had before, but you're going to have problems where you may have to substitute something in like this. And I want us to talk about how to do this, and then I'll go back and look at how we could have done it easier, okay? But what is 2 square roots of 5 times 2 square roots of 5? 4 square roots of 25. When you are multiplying, you will multiply the 2 and the 2 and the 5 and the 5. Okay? What is the square root of 25? 5. So we have 4 times 4 times 5. 4 times 5 is what? 20. So we have 4 times 20, which is 80. Okay, so the measure of angle K is 80 degrees, which means so is the measure of angle J. Now, Naya said, why are we doing that? You can just go back to, instead of plugging in 2 square roots of 5 for y, what did we say y was equal to before we simplified it? The square root of 20. So you could plug in the square root of 20. Or what Anna said a few minutes ago is you don't need to do that because we solved originally and said y squared is 20, right? And all we needed was y squared. 4 times y squared. What is y squared? 20. 4 times 20 is 80. Okay? So we could have easily done that, but not if I said, what is the value of y? If I ask you for the value of y, you've got to go further, simplify your square root, put your plus or minus. Questions? Okay. We're not going to do the last one. It's the same kind of thing. Homework is due on Monday. And I need to warn you, this is probably the longest assignment you're going to have this year. It is long. It's not super hard. Some of the questions are going to go really quick. It's just what kind of triangle is it? Acute, obtuse, right, equilateral, equiangular. And I am warning you, it is long. It is not something you want to save for Sunday night to do. You need to start it. Work a little at a time. Call or text me if you have questions. It is long. And there's one thing I think that crops up on this homework. Can you guys take your slip and write this down on your slip? Because you'll probably have a question if you don't. So look up here really quickly before the bell rings. If they tell you that a triangle's angles are in the ratio of 2 to 3 to 4, pretty sure it's on this assignment that this comes up. Triangles' angles are in the ratio of 2 to 3 to 4. That doesn't mean that the angle is 2 degrees, 3 degrees, and 4 degrees, because that wouldn't add to be 180, right? All that means is that if you were to simplify them, they would reduce to 2 to 3 to 4. So what you can do is you can say one angle is 2x, the other angle is 3x, and the other angle is 4x, because there's some value they have in common that's going to reduce away. Does that make sense? Think about it. Look at the homework. If you have a question, don't hesitate to call or text me, okay?